Assalamualaikum warahmatullahi wabarakatuh. My name is Alia, Binti Mohamad Zailani, metric number CE190192. So for this chapter 9 Earth Leakage Delay Test, I will explain starting from number 1 to number 4. So in this slide, we'll have explanations for function of ELR, current and time setting in ELR, time leakage indicator, connection of ELR to ZCT, bus bar and MCCB, function of ZCT, bus bar and CCB, and lastly function of pin of ELR. So first question begin with, what is the function of earth leakage relay? So according to the figure 5 in lab sheet, there was an earth leakage relay ELR with model MHEL03 that used in our laboratory here. Okay, so this ELR, earth leakage relay, or also known as ground fault relays, are residual current monitors, RCMs, that are used to detect potential dangerous ground fault currents before they cause any hazards. Moreover, an earth leakage relay is a device that used to sense earth leakage and open a circuit breaker when the leakage current exceeds to the preset value. It also can protect human beings from electrocution or prevent fire hazards. So, earth leakage relays are used in combination with core balance current transformers, CBCT or zero current transformer. In conjunction with an earth leakage relay, also used for the protection against electrical leakage in the circuit. When somebody gets an electric shock or the residual current of the circuit exceeds the fixed value, the relay can cut off the power within the time of 0.1 second, automatically protecting the personal safety and preventing the equipment from the fault result from the residual current. With this function, the relay can protect the circuit against overload and short circuit, or can be used for the unfrequent switch over of the circuit under normal conditions. So, what is the time and current setting for this earth leakage relay? Okay, so this earth leakage relay's current setting is 0.03 till 30 amp, and the time setting is between 0 till 5 seconds. What about the real-time leakage indicator? So, real-time must monitor from the percentage of leakage current. Next, we move to the question number 2, which is connection of earth leakage relay to zero current transformer, bus bar and molded case circuit breaker. Okay, so in this lab sheet, figure of earth leakage relay in low voltage switchboard is given. It consists of 4 wires, which is red, yellow, blue and neutral. So the incoming from the main bus bar is connected to the molded case circuit breaker. The zero current transformer is connected to the pin 1 and 2. So next, the molded case circuit breaker and line neutral are connected with the shunt plate. In the normal conditions, current in phase and neutral earthing are balanced or equal. But when the earth leakage occurs, the zero current transformer will detect the unbalanced current flow, and once earth leakage relay gets the signal, the shunt plate coil of MCCB will get power supply and it will treat the MCCB. Okay, so next we will continue to the question number 3. Function of zero current transformer, zero current transformer, bus bar and molded case circuit breaker. So first we have zero current transformer. So the zero current transformer are differential sensors passing both line and grounded neutral conductors into the current transformer aperture so as to make a zero phase sequence in the case of leakage current or fault current on the line. So it is called the differential current as the sensitivity current distinguished from the primary current. The zero current transformers protect the power system against leakage and earth faults. Each of these current transformer has an insulation level of 0.72 kilovolt and requires a suitable insulate primary conductor. When the leakage current at the current transformer primary reach a certain level, the current transformer secondary provides the necessary current signal or voltage signal according to the type of the protective relay in use for the protection of the power system. Okay, so next we have bus bar. So bus bar was built to protect the panel associated electrical apparatus such as circuit breakers, incoming and outgoing pole contacts, isolating switches, including earth switch, potential transformer, and current transformer, and etc. Okay, so last we have molded case circuit breaker, MCCB. Okay, so MCCB is another type of electrical protection device which is used when the load current exceeds the limit of a miniature circuit breakers, MCB. The MCCB provides protection against overload, short circuit faults, and also used for switching the circuits. It can be used for higher current rating and fault level even in domestic applications. The wide current ratings and high breaking capacity in MCCB find their use in industrial applications. MCCB can be used for protection of capacitor bank, generator protection, and main electric feeder distribution. It offers adequate protection whenever an application requires discrimination, adjustable overload setting, or earth protection. So last question, we have function of pin 1, 2, 7, 9, 10 and 12 in earth leakage relay. So pin 1 and 2 are used to detect the current flow at zero current transformer ZCT and as communication medium for earth leakage relay ELR and zero current transformer. Okay, so both pin 7 and 9 is used to provide the auxiliary power supply to the relay. But the difference is pin number 7, pin 7 is at negative terminal that connect to the neutral line, and pin 9 is at positive terminal that connect to the red line. So pin 10 is used to treat the shunt coil for relay that connect to the normally open of MCCB. And lastly, pin 12 is normally open that always on when the current exceeds from the set value of earth leakage relay. So I think that's all from me. I will pass the rest of questions to my partner, Tharnisha. Thank you.
A very good day to lecturer. I'm Tharnisha Sithanathan and my matric number is CA190099. So today I'm from group A5.4 going to present on the chapter 9 Earth Leakage Relay Test Laboratory Sessions. So I'm going to continue the presentation by one Anis Alia from the explanations for question 5 to 8. So as you can see here, these are the questions I'm going to explain. which is question 5 on the functions of secondary injection test set. Question 6 on the connections of the secondary injection test set. Question 7 is the method to perform the E-alert test using the secondary injection test set by checking the minimum current settings. And finally, the methods to perform the E-alert test using the secondary injection test set for checking the minimum operating settings. So, for the first question, function of secondary injection test set. Secondary injection test set is important to analyze the correct operation of circuit that is being connected while ensuring that the trip functions of the protection relay are in the range of the specifications mainly specified by the manufacturer. Figure in this slide shows the secondary injection test circuit that being used commonly in laboratory, which is a Mega SCITS 100 with maximum rating of 100 ampere, 18 kVA and a built-in timer unit. Moreover, auxiliary relays, protective relays, metering devices, low voltage devices and protection circuits are some of the secondary protection systems that can be tested by using secondary injection test set. So this test also simulates the voltage and current from the transformer secondaries by applying either single phase or three phase voltage and currents into relays by performing all the important testing with faulty and normal conditions. So, by moving to the next question, which is connections of secondary injection test set to the ELR, which is earth leakage relay. So, as you can see here, we have pin 1 and pin 2 which connected to the input, pin 12 and pin 10 which is connected to the timer and stop respectively, and pins 9 and pin 7. So, let's see on the methods to perform the E-alert test using the secondary injection test for checking the minimum current setting. Firstly, the secondary current injection test wiring connection should be as this figure that was implemented to check the minimum current settings. Then, to induce a secondary current on the ZCT, a single phase current was injected into one of the primary conductors to induce a secondary current to the ZCT. Most importantly, before conducting the test, it was ensured that the primary circuit of CT been de-energized. Then, an external voltage source of 200 volt was supplied to the ELR while the secondary current injection test set at 0 to 10 ampere range and 0 to 240 volt AC operation. Finally, the output current of the test set was increased gradually until the ELR elements peak out, and finally the secondary current injection test set was switched off. So, last but not least, let's see on the methods to perform the E-alert test using the secondary injection test for checking the minimum operating settings. Firstly, to check the minimum operating setting, a relay trip contact was connected to secondary current injection test set timer terminals as shown in this figure. Then, the secondary current injection test set was switched on and the output current was set up to 2.0 times I/O and 3.0 times I/O, which is tripping current settings. After that, by remaining the control knob in the set position, the test set was switched off while the set current was injected, while the timer was started by switching the secondary current injection test to test position. Lastly, all wiring set between test set and relay were disconnected while ensuring that all the connections to relay were returned to the normal operational conditions and test set was switched off. So, that's all from me. Thank you for watching.